Welcome. In this video, I'm going to talk about intervals of increase and intervals of decrease for functions. One of the easiest ways to analyze this topic is to imagine your function as a profile of Earth that a person can walk on. I'm going to draw the person at several different locations and try to imagine what it might feel like to walk through this contour, through this cross-section of Earth. Sometimes the person would feel like they were at a peak, which is the highest point in their local vicinity. Now, where does the peak happen? Right here, I see a peak. It could be thought of as a mound or a mountain, perhaps. It's a high point relative to the other points that are close to it. I also see that here the person is in what's called a valley. And here's another valley. Those are the lowest points in the local area. All right, now the reason I bring up peaks and valleys is we want to subdivide our interval into sections using the peaks and valleys. Where do those valleys and peaks happen? Well, there's a valley at an x of 1. There's a peak at an x of 3 and another valley at x equals 4. All right, so one other important question is, which direction is our person walking along this profile? Well, in math, conventionally to the right is the positive x direction. And we want to think about ourselves walking to the right. Now that we have that settled, we can decide when our person is going uphill and when they're going downhill. If they're going uphill, it's called an interval of increase. If they're going downhill, it's an interval of decrease. So I think that from x equals 1 to x equals 3, we are going to be increasing. And also from x equals 4 and beyond, we're also increasing. So when I go to describe the interval of increase, I want to say that we're increasing anywhere between 1 and 3. That's called algebraic notation. And there's one more interval where we're increasing. That's whenever we are at an x greater than 4. Could leave it like that. Or if we want, we could put in the optional infinity. Okay. That's great for algebraic notation. Now what we need is interval notation. We're going to say the same thing in a different way. You have to put the start of your interval of increase and then the end of your interval of increase and put them in parentheses. But keep in mind that we're only going to use the x values in this interval. So the start of our interval is at x equals 1, and then we stop walking uphill at x equals 3. Now, should we include the 1 and the 3? Some textbooks do, but I would say that most do not. I'm actually going to not include the valleys and the peaks as part of the interval of increase and decrease. And there's one more interval to list in interval notation. We'll go from 4 to infinity. And now it's done. Can we list the intervals where we're decreasing? Well, that would be from negative infinity to 1, and also from 3 to 4. This is a decrease. And so is this. Okay, great. Now in the lower right, let's do the same thing. We have to identify the peaks and the valleys, first of all. Here's an important point, but is it a peak or a valley? Well, I can draw my guy walking across the profile. And this is a low point that he's at here. And so for that reason, I'm actually going to call it a valley. Similarly, I think that this is an important point there, but I want to analyze it by imagining my guy walking and see if he has to walk up to get to that point, or does he walk down to get to that point? As you can see, he's got to walk up to get there. So it's actually a peak. Anyway, we will subdivide our interval. And another point where we should subdivide it is at the x equals 0. It's a little tough to tell what's happening there. There's an asymptote. So our important x's are -2, 0, and 2. All right, now let's list our intervals of increase. So I think that as we walk to the right here, our guy has to walk uphill in order to move to the right. But then things change. After that, he's decreasing. I see here that our guy decreases to get to the valley. And then it's going to be increasing after that. The intervals would be from infinity to -2 for increase, and also from 2 to infinity. And we always use parentheses with infinity because there's no real number that represents infinity. It's just a concept. And I also want to use the parenthesis with the 2 because, like I said, at that point, you can't really tell whether you're decreasing or increasing. You decrease to get to the valley, but you increase when you leave the valley. So that's why I won't include the 2 or the -2. Where are we decreasing? From -2 to 0 and from 0 to 2. I don't want to include 0 because we can't really tell what's happening at that point.